Welcome everyone. Welcome to Malware Development Part 6. And this lesson is quite important. Here we are going to explain the basic data types, the basic workflow of the code itself, and from there we can build on top of that into compiling and doing more complex logic. Now that's important because if you understand this lesson quite enough, you will have the ability to perform coding on any language whatsoever. Why is that? Because here we're going to explain how the code generally works and the basic variable types. So let me first draw some kind of a tempo code, and then we can, based on that, do and explain the things. So first I'm going to include my str.h, which is the main library we're going to use. And then I can define my main method. The main method is the method that tells the program from where to start executing. So here this is my main, and I'm gonna printf something super simple like hi. Okay, now after the printf statement, I'm gonna do something different now. I'm gonna assign four types of variables. So we have int, number is equals to 5. We have float number equals to 5.5. Don't blame me on the naming convention. That's I'm bad at that. Then we get to do double number equals to 4.5, and then we have char character equals to C, just like that. Now, this thing you see on the screen are the four main types of variables which are inside the C language and inside each machine you can touch. Now, I know that Windows itself has a lot of its own data types. I know that there's a bunch of new things like structures, like and so on, but we're gonna get into this a little bit later. Now, I think it's important to explain the very basic of data types, how it works, and how the code works. All right. So the first data type is integer, which resembles a whole number. Then we have a float and a double, which both of them resembles not a full number. So it can be 5.5 or anything in between. So it can be with a huge range of numbers. And all of these things can also have a negative values. So it can be -5. No problem. Then we have a character, which is just a simple ASCII representation character, just like that. Now, you may have also strings, which are, by the way, an array of characters. So it can be string equals to test. But I'm not touching on that because at the end, it's a combination of different characters which resembles a string. So at the end, it's a character data type. Okay, so the main idea of the code is to utilize variables and do something with them. And that's about it. Based on the solution you have to do, based on the problems you face, you have to literally get used to the variables and do some logic with them. The main types of variables are the following, but how we can do logic with these types of variables? Logic is done with something called whoops or if statements. So with this, we can pretty much force our code to do something based on specific conditions. So I'm gonna draw that because I think it's easier to explain it. Imagine this is the code we have. And the code we have must have some kind of a logic. So it must do something, otherwise it's not needed. So in order for us to create something, it must have a different kind of logic. And the logic is explained by steps. First is gonna do that, second is gonna do that, third is gonna do that, and when everything combines, we have a nice logic. For instance, if we want to do some kind of a concatenation or let's sum to numbers. Let's do that. Let's create the logic of summing to numbers. So I'm gonna write it here, some numbers, and how the logic is gonna start. We're gonna have assign number one. We're gonna then do assign number two, and then what we have to do is obviously sum them. After the sum is done, then we have the result, and our code completes. So pretty much that's about it. So if the idea of our code is to sum two numbers, how we can actually do that? The first thing is to obviously directly sum the numbers inside the main, but that's not a very practical thing to do. And what it's always best to do, as one of the best coding principle out there, is that you have to do different functions, and each functions have to do only one specific things. So avoid using nested functions or avoid using complex functions that do many stuff. Keep your code simple, guys. Use one function for one specific thing. In our case, sorry, the main functions is where the code starts, but we want to create our sum up logic in a different function because that's how we keep the code clean. So here I'm going to do integer based on data type, and I think it's obvious and better to use double here. So because number can be not full number, then double, let's call the function sum up like that. And here let's accept two more numbers. That can be double and one and double and two. So what I always like to do is to define the function signature. I can define the function signature by pasting it below the input statements, and here not expand the body like that, but finish with a semicolon. With that, I tell the compiler and the code that I have this function inside my code with this signature, and so that it can be used. This is a best practice because this way you ensure that you use a function with specific signatures, and if you change it here, you can also change it there. So if any other developer looks at the code, he can see, aha, so this code is actually doing that, which is so nice. Now inside my sum-up function, as mentioned before, we want to sum two numbers and then return the result. So in that case, it's going to be double result is going to equal n1 plus n2, and then we're going to return the result. If you want to keep the code cleaner, we can directly do return n1 plus n2, just like that, and it's pretty much the same thing. Now, here we need to call the function, pass different values, and then move on. So here I can do double number equals to 5.9, and then double number 2 equals to 111.59, and then double result equals to sum up number and number 2. So now we have the result inside here, and we can print the result. So I can do print percent, let's call that lf, and then here we can do result just like that. So if I compile the code now and I run it through the debugger, I should see, oh, sorry, we have some kind of an error. It's print f should be the call, run that, and we can see pretty much the result. Okay, now let's walk through that code and explain everything step by step. So, as mentioned before, first we need to define our libraries that we need to use. As mentioned, libraries are a bunch of code that we can use in a form of function. So in that case, a function inside stdio.h is printf. So if we remove that, we will not be able to use printf in the first place, which should give us an error by compilation. Yep, there it is. So by including the library, now we can use the printf because the printf is a part of this library. After that, we define all of our function prototypes. This is just to tell the compiler and other developers what functions you have in your code, so that when I come back and I didn't write that code, I can just by the signature see what the code is doing on a very basic level. So I know that now, so it sums up different numbers and returns a double result, which is so nice. Then we have the main method, which is where the code starts. It's not going to start from here, it's going to start always from the main. Inside the main method, we just have a printf statement high just for testing purposes. Then we define two numbers. Then we sum the numbers by calling the function and saving the result in different variable, and then printing this variable. So, as mentioned before, in order to operate with the code, we should have some kind of a variables. Otherwise, it's going to be painful and it's not going to work in the first place. Of course, we can directly sum them up using some kind of shady representations, like directly call the function and so on. But saving in a variables is always a nice thing. And now when you have variables, you can work with that. For example, let's add more logic to our call. Now here, instead of just saving, I want to check if my value is less or bigger than 100. Let's call very simple logic. So here, I'm going to do an if statement like that. And in this if statements, I'm going to check if value is bigger than 100. If it's bigger than 100, then we can do one specific things. And if it's not bigger than 100, we can do other different things. If is logic subtractor. So maybe subtractor is not the right word, but logic separator. Yeah. So I think that's better. When you have these statements, you can create a different workflow based on what happened in certain time and space. And that's the magic of this statement because it's used a lot, so better get used to doing that. For example, if we don't include these statements, our code is only going to do that specific thing at the moment. You're going to have one number, you're going to have another number, then you're going to sum the numbers together, and pretty much that's it. You're going to return the result and execute again if needed. However, if we include if logic, now we can do many, many more stuff. Because here, if the value is, for example, bigger than 100, we can do one specific things. And if it's less than 100, we can do another specific things. And we can include if statements, in if statements, in if statements, in if statements, and so on. So here, based on that, we can separate our logic into very different logic based on what happened in runtime. So based on the number itself, based on the result, we can do different things and implement different logics. Let's just do that. So here, we can create again new function. Let's call this function void because void is a data type which means nothing, do not return anything, any type, no type. So inside that, we can do a function called, let's see, scan number, like that. And we're going to have this time only one parameter, which is going to be double and number to scan. Then here inside the logic, of course, we need to again include that as our signature because that's how we keep the code clean. And here we can define one if statement. So if number to scan is bigger than 100, then here we can do something. So in that case, we can just printf the number is bigger, else printf the number is smaller. So what happens here is that we have a function which is capable of scanning a number if it's bigger than 100, and then a custom logic can be done. So for instance, we can do the number is bigger, we can, if it's bigger than 100, else we can do a number is smaller, and we can do something like exit here because we want to exit the program if the number is smaller. And we can also point that out, saying that exiting now because this failed. So now we need to call that. Since we have the result from the first step, like from the sum up function, now we can call our new function to scan the result and then move on. So here inside this function, I'm gonna call it like that, copy that, paste it here, and just remove the signatures numbers and just call it with the result itself. So paste the result here, save that, run it, and let's see now what happens. I run the code, we can see the number is bigger. Why the number itself is after the number is bigger, print statement, is because we have the printf here. And this gives me one very important thing to explain, and that's how the code executes on when you run the program. So imagine it like that. It always starts from the main method. Before executing the main, it's gonna of course get all the signatures to resolve the functions having the code. It's also gonna include all the libraries we're gonna need, include all the modules that the library use, and then start the execution from this point on. From this point, the first thing he's gonna do is actually I'm gonna set up a debugger here to actually explain you guys how the actual thing happens. So I'm gonna switch to debug, when you set up click here, you're gonna see one red dot. This red dot means breakpoint. So as soon as you execute the code from the debugger and the execution flow comes to here, the execution is gonna stop, and you have the ability to scan what happens with your code in runtime. That's also called debugging. So when I run that with the local Windows debugger, now I'm on the breakpoint. We can see breakpoint is hit, and pretty much I'm seeing nothing on the screen. Now, if I run step over or step into, now I don't have functions, so I can do step over, and it's gonna move one line at a time, executing the next instruction. So by doing that, now we have a variable called number. In that case, we can see the number is 5.9, and we can see it right down in the top left corner. Then I can click step into again, and then we have two numbers, which are explained here. So we have number one with the value 5.9 and number two, 111.59. So that's how we define variables, and that's how they are saved into memory. So each time you create a variable, this variable is saved into the memory of the process created. You may ask, what is the process created? Well, if I open a process hacker 2 and I type the name of my application, which in that case is my first program, we can indeed see there's a process corresponding with this program. So each time you start something, this starts a process inside your operational system, which has its own memory. And when you create variables, the memory of these variables is inside the process itself, which of course uses RAM, but we're going to talk about that in the next episodes. But that's super important to remember. So all these variables are inside the memory space of the created process from your program. Cool. Then we have the sum up functions. Now I'm going to do step into because I want to step into the functions and see what happens. Inside there, I see one more number which is double result, which in that case, when I do step into one more time, we see the value is 117.4900 and something. Then I'm going to do step over again. And here, see where I am now. Back here. So here, we defined number one, number two. Then we executed the sum up function, which means that we executed row 21, row 22, and then we get back to row 13 where the function actually is. So I can do step into again, and then we have another function call, which in that case is scan number. In that case, I'm going to do step into again, and now I am back here. I still don't see the printf statement saying how much is the result because now the function is queued to execute. When I do that, I can move in a little bit, do step into again. I can now implement this statement, scanning if the number is bigger than 100. And in that case, it is bigger than 100. I can do step into again, step into again. Else statement is not executed because that's false. It's not bigger, it's not lesser than 100. And here, boom, we are back. So then, and just then, I can execute the printf statements saying how much is my result. And now the number is bigger. If I do step into, we can see the value itself. It's very important to debug your program. Why? Because debugging your program allowing you to see what happens on runtime with your logic, with your variables. You can see all their values and you can actually observe what happens in runtime with your code. And that's super important. That was it for today's video. In the next one, I'm going to speak about for loops, while loops, switch statements, and these are also ways of how you can engage with the variables, aka with the memory, and then execute different things based on runtime environment, as we did now. For now, it's key to remember how the workflow actually happens. It's key to remember that when you execute a function, this function is executed first, and when the result is there, then you can move on down the line. It's not like that, and then the functions. But when you call the function, sum up is executed. When you call scan number is executed, and then you move down. So it's also key to remember that if statements is one of the key components of the code. If statements is the logic separator, which means that using if, you can separate your code and add different logics based on what happened in runtime. For instance, now here I can do minus 55. So in that case, when these numbers are summed up, I'm gonna have a number lesser than 100, and then we're gonna call exit procedure. So here we can do again debug that. I can go step over, and here on the function, if you type step over, it's gonna execute all inside the functions, but it's gonna break to the next line. So remember in the past, in the previous example, we did step into, which gave the pointer, the execution pointer, to the function itself. But now if I do step over, see what happens. Boom, I'm back to the scan number. Boom, I'm directly exited the application because the exit happened here. So if I run that again, let's imagine now that I know what happens from sum up. I want to skip that. I do step over, but then I want to see what happens specifically in scan number. So I can do step into. When I do that, I can now do step into, and see the this is less than 100, then the else is executed, which means that now we have printf the number is more, exiting now because of the because this failed, and then we call the exit process, which is gonna stop the process and exit the debugging program. And with that, it's important to actually see what we can do with these statements. And in future, we have to use it all the time because we can always pass arbitrary values, and how you can control the workflow is just with such if statements. So with if statements, you can perform conditions. You can do all kinds of check to your code if all the values are the one you expect and so on. And if you see some kind of error, exactly with if statements, you can just redirect the workflow, exit the code, and throw exception if you have any exception with the language you use, and pretty much do what you want. In the next video, as mentioned, we're gonna do stuff like cycles, so we can see how we can operate with variables, again, in runtime, doing different calculations, combining things together, and I think it's gonna be super fun. With that, I wanna say massive thanks to my Patreon sponsors, which made this course possible. I am doing that specifically for my patrons, and I appreciate every single one of them. If you have further appreciation, you can become my patron, where you can have other videos from this course, which is actively being developed at the moment. You can also get access to Shadowboard, my private tracker, alongside with other useful projects. However, if you don't want to become my patron but want just the course, you can freely buy it from the same platform. Thank you so much. I hope the video was useful. If so, drop a thumbs up button, subscribe to my channel, and I'll definitely see you in the next one.